Good afternoon, everybody. Thank you for joining us today. This is Shawn with Mondale Associates. I'll be conducting our training today for Liberty Supply on water quality, utilizing Fernox as our basis of information. So today we want to really start talking about, the purpose of water quality in a hydronic heating or hydronic cooled system, from the understanding that there's system water that is going to be placed in these different types of systems and what the counter effect is if we're not dealing with the level of pollutants that are in those different systems. So we're looking at a time-lapse video of a system that was both put together, one having Fernox, our protectant product, our F1 that we're going to talk about in a little bit, and another particular product that after 7 days, you're seeing just the reaction of just standard water with a steel component inside of that water system. So we're just trying to give you an idea of kind of what we're talking about. When we talk about, water quality, we talk about different aspects. One is operational costs from the standpoint that if we have a system that is, plugged up or sludged up or full of corrosion, the operation costs of that system to put the energy from either any type of heat exchanger that you're going to be utilizing and putting that energy into the physical fluid to create your energy transmission is going to cost more money because you're going to have that system running for a longer duration in that system to create that same operational efficiency. So it's going to have a better or worse operational cost. Obviously, maintenance costs, we're going to talk about, how this affects heat exchangers and components such as valves and strainers and different things that are going to be in your system. You're going to have to replace those more frequently, and you're going to have to do maintenance to those to keep them from leaking and from failing prematurely. There's a risk exposure to the owner of whatever facility we're talking about, whether it's a residence or we're talking about a commercial building. A lot of the manufacturers of different pieces of equipment and components are no longer going to warranty things that are failed due to water quality issues. They don't feel like that's an installation issue. They feel like that's a failure from exposure to the water quality that is in that particular system. So that brings up obviously liability from the standpoint of failures, liability from, if we're talking about a boiler heat exchanger, we plug up a boiler heat exchanger with water quality issues, we're going to increase our vent temperatures and potentially fail our venting, which obviously creates another status of liability. So we were talking about all those different types of components of why are we doing this, or what is the purpose to water quality. It's not only something to do or just having the ability to keep a clean system, but it also has some counter effects and some financial costs to the system owner. So we're going to talk about systems from all types, so all metals, so aluminum, copper, galvanized steel. A lot of these components or these metallic fittings and valves are in different systems, and our products that we're going to talk about today are going to work with all of those exclusively. So we're not going to have one product for one type of system and another product. It's going to be a single solution for all of the products that we're going to be talking about in a heating and cooling system. So one of the counter effects that we've been talking about is heat exchangers. So when we talk about water quality and displacement of failed components, usually it's going to start at the hottest point of that system. So in the case of a heating system, it's going to be your boiler heat exchanger. So there's a picture of a failed boiler heat exchanger after 18 months with a system that had bad water quality and the water was not treated. So you can see from the burner side, so the top of that unit is the burner side. And from that down, we're starting to see the buildup of the scale, the hardness, and in this case, iron oxide, which is the byproduct of black iron or steel piping systems. So these are things that we're seeing as realities. This is a cutaway from the manufacturer from that standpoint to kind of see what that looks like. These are other exposed heat exchangers to poor water quality. And again, you got to remember the burner is trying to put energy in through these tubes and putting that into your fluid. So at this point, we're trying to circumvent that by pushing through that. So it takes more energy. Obviously, as the burner heats from the inner side of that tube, you're going to have more weak points because now we're going to be overheating these products where they normally would be transferring that energy into your fluid from that standpoint. So these are byproducts of that. When we start to overheat heat exchanger tubes from the burner side and we have sediment on the opposite side, those heat exchanger tubes will start to expand and contract. Eventually, you will end up having pinhole leaks in heat exchangers and different other components, leaks from that standpoint. So obviously from a heat exchanger standpoint, this is a place where we're starting to see more issues with heat exchangers being denied, because this is not a failure of the heat exchanger. This is a failure based upon the fact that there was water or fluid in the system that caked up or build up so badly in the system that the water could not be transferred anymore, and the burner overtook the metal from that standpoint. So the inside of that heat exchanger, this is what that would look like. So you have the buildup. So the bottom side of that heat exchanger on the picture on the left, we're looking at the buildup. So that burner has to now fight through all of that sediment and all of that buildup. So at that point, it's exposing the metal to extreme temperatures that it's not designed or meant to be around. And then we have obviously lower flow. So that means the water is sitting in that heat exchanger for a longer duration, creating an overheated component, which is going to stress or put additional stress on that metal. So it doesn't matter if it's a water tube that's a flattened tube or a circular tube, you're going to have issues with any type of heat exchanger that you're going to have water quality that is not proper for that particular system. The other byproduct is because we're now going to start to overheat that water because we're slowing the flow down. Water is now sitting in that heat exchanger for a longer duration. We can start to overheat components. We already mentioned venting. This is an application where it overheated the controls and melted the controls right off of the side of that heat exchanger. So those are all byproducts or component failures of that water quality not being proper inside of that heat exchanger. It doesn't stop at the heat exchanger. So when you get out into the system, you'll see in different applications such as valves and different components, you'll see that there was a leak at one point, and sometimes you'll see different applications such as copper piping system where you have kind of an aqua color across that system. That's what happened here. Is we had some eroding or corroding copper pipe, plugged up a snow melt system, and then the system stopped flowing. So then we couldn't obviously do the proper job that we were looking to do for that system. It just plugged up with the sludge and the breakdown of that copper piping systems. So there's some visual inspection you can see in the mechanical room. So when you're walking through a mechanical room, if you see that aqua color on your copper pipe, that means there was a leak. Copper breaks down as a liquid and it'll dry that is similar aqua color. So you can see rust spots on steel, wiped calcium buildup, that's corrosion that has escaped out and then dried from that system standpoint. So we're going to be able to also have visual examples of why that water quality has started to come into the system. So we're going to work with all the different types of metals out there, whether it's a cast iron radiation fin tube, whether it's a PEX or a steel radiator, such as a panel radiator. All of these types of systems are going to be components that we're going to need to deal with water quality. No matter what the system is, if we have mineral or we have any kind of broken down sediment, we're essentially going to be etching at the inside of the piping system. So even if nothing else is off, we're still going to be eroding that internal system based upon the mineral and obviously the coarseness of that product that's going to be inside of your heating system. So the basic two problems that we run into the most commonly, we're talking about heating and cooling systems, is corrosion. From that can be from a pH level that's in the state of alkalinity or from the state of acidity. So we're going to be talking about those two different pieces of the puzzle. We're also going to be talking about limescale. So limescale is the mineral that's in most of the water that we run into in the Midwest here. So as we go down and drill our wells, as we pull, get into the aquifer, sometimes an aquifer is surrounded by limescale, and that comes up with the water, and that's what is going to plate or stick to the inside of the heat exchanger. So there's some places where the water comes from the river, so we're not going to have so much a limescale issue because it's coming up from the water bed instead of going down into the aquifer, but we will still have a corrosion problem from a level of pH. In a lot of cases, that still has a pH issue from that standpoint. So we're going to talk about how the system is put together. So when we go to the system and we're going to assemble, you're going to have a mix of steel and copper and PEX and stainless and different metallics. Then we're going to get into some of the chemical components. So, if you're using press fittings, you have silicone as the lubricant that they use on that system. When we get into any kind of solder joint, you're going to have flux, and you're going to have Teflon tape, and you're going to have pipe dope, and you're going to have all of these different components. And then we're going to have that connected all together. We're going to run our fluid through that, and inevitably we're going to pick up some of those products. Not that any one of them is bad, but we need to deal with the fact that that material is going to end up in our fluid for our heating and cooling systems. Because of that, it affects our water quality. So even if we had perfect water, or perfect fluid, no matter if it's a glycol-based solution or it's a straight water-based solution, we're going to inevitably have a change into our fluid from that standpoint. And specialized water doesn't always help. Sometimes when we do different water treatment, such as doing an RO or softened water or DI style water, when they are heated or put into different applications, they can actually be more aggressive than straight water right out of the tap. So we don't necessarily want to use any specialized water when we're talking about this type of application when we're going to be treating with our Fernox products. So obviously on the black iron side or the steel piping side, we end up with a byproduct called black iron oxide, or you might have heard the term bio. So bio barriers for pumps and different things of that nature. Seals and magnetic filters we'll talk about today get into a lot of the black iron oxide components. And that is essentially the breakdown of any of the steel components in the system, whether that is galvanized, whether that is straight steel or cast iron. When that breaks down or starts to erode or corrode, when it leaves the component and goes into solution, you're going to see these black or kind of brown rusty water. That is a byproduct of that steel pipe called black iron oxide. And because we're dealing with dissimilar metals, we're componentizing them, we're putting fittings and different applications that are going to connect from one to the other. We may have perfect water going into the system, but even if we had perfect water, by the time we put it through these different metals and deal with all these other chemicals and pollutants that are in the system, we're going to eventually have to deal with the fact that the water is not going to be perfect any longer. So with the dissimilar metals, we do need some kind of inhibitor to maintain its integrity for the duration. We need to make sure that sediment and corrosion do not happen from the inside out. So we're going to really start to focus on how we're going to balance and maintain that system so we don't have breakdown of all the different materials from that standpoint. So we're going to try to add that inhibitor to protect our system from breaking down any further. Obviously, on top of that, if we add oxygen to the system, most hydronic systems are pressurized, which means we're going to remove all the oxygen out of solution and try to get that out of the system. But obviously, there is always a level of oxygen that's inside of that system, or if we're in a non-pressurized application, we would always have the readmittance of oxygen. Or if we're doing a non-oxygen barrier PEX tubing, that's another place where oxygen can intrude or come back into the system to understand how that comes about. We talk about lime scale. We're going to talk about the ability for the lime scale to come out of solution and to plate to heated surfaces. So some of these pictures you're looking at are what the byproduct of that is, which is obviously reduced flow, blockages, and then potentially overheating of those different components as far as that's concerned, which is going to relate to costs of running the system and operation and effective efficiencies, both at the fact that your stack temperature will start to increase on a boiler system. You're also going to have longer run cycle times, which means all of those cases are going to create more cost at the fuel or the utilization side. So no matter where we work in our market, we're going to be able to see that there's going to be hardness in every level or every area that we focus on. Typically, we're dealing with a 16 to 30 grain hardness levels. We've seen as high as 130 grains of hardness in our market. So there's definitely some very good places that are going to have to be dealt with from that standpoint across pretty much our whole footprint that we're dealing with. So we're talking about that. So depending where you are, you can have, the hardness based upon lime scale. There's other places that we go the other way, and there's more of a salt bed in the water. So it's really depending on where your ground source or where your groundwater is coming from is going to determine where that is. And then obviously once we enter the system, what are the contaminants being created by that system? So the biggest problem with water quality overall is if I start with a brand new system and I flush it out and I do all the right things and I install that system and I don't inhibit the fluid that's inside of that heating or cooling system, we were going to rapidly start to lose efficiency. So this is a case study that was done in a 3-week period where we put a brand new standard efficiency boiler in. After 3 weeks, we went down from 87.4% efficiency right down to 81. And then the thought would be is, well, I go and clean it and then everything will come back to normal. Well, that doesn't always happen correctly. So in this case, we, after cleaning and descaling and trying to do the best job that they could, they got it back from 87% up to 84. So there's still a 3% efficiency loss, at the fuel stack or the fuel bill from that standpoint. So It came up a little bit after 2 more weeks of just running, but it's really stabilized at that 84. So we essentially lost 3% of our efficiency. Because we have cleaning products out there doesn't mean we can get rid of all of the stuff that's in the system. We can do a good job to get as much as we can out, but there's always going to be residue or sediment left behind. Same thing if we look at different types of systems. We go out to a different application where we have a boiler that's installed in a residential application, and it wouldn't really matter the application style because all of these examples are really just a correlation of how it would affect any hydronic system, whether it was commercial or residential. And even if we go out there with our cleaners and do all the best thing we do to inhibit the products, what we end up finding is our run cycle time is still, inhibited or has been changed because this water has fouled up the system far enough, and no matter how well we clean it, we can never get it back. So obviously doing this from the get-go and maintaining our water quality from the system start to obviously during its life or during its life cycle, that's really the important piece of the puzzle that we're going to talk about here. And the bigger problems are transmission energy. So we're going to talk about, we've talked about AFUE and, doing a combustion test and seeing what the combustion efficiency is, but now we're going to talk about the thermal transfer energy and how is that affected. So in this same particular application, we had, the radiators were kind of fouled up as well as the heat exchanger that we just talked about. And before cleaning, the best temperature we could get out of it was 93 degrees. After we flushed and cleaned it that first go around, we got it from that particular temperature up to 139 degrees of discharge temperature. So that's an amazing amount of difference in discharge temperature, obviously, and that's going to relate to your cycle time. And then finally, after flushing it again and getting into another place, then we get to a place where we get up to full temperature. So we're getting better temperature out of that system. We may not still be getting complete full temperature based upon set point, but we're going to get a lot better than that 93 degrees we started with. So if we have an aluminum boiler heat exchanger or aluminum products in your system, they are even more sensitive to water quality. So if you look at your manufacturer's installation guides, they're going to talk about pH levels. They're going to talk about how oxidation and corrosion from the likes of limescale are really going to be a factor. And again, this is places where you may not potentially be able to have a system last very long or get warranty if it does prematurely fail. These are all applications that we're seeing, as a byproduct or a secondary factor to water quality. Because we're going to look at cleaning the systems and different things like that, obviously the higher the temperature we can run that system out is going to help us get as much of the debris out as fast as possible. So that's something that we want to talk about from that standpoint. And then obviously at the end of the day, we're really going to end up with a system that's full of water that has, particulates that are going to inhibit flow, that are going to inhibit heat transfer. At the end of the day, are going to affect your AFUE of your system. So what we're starting to find, even from most major manufacturers of different components is, a lot of the failures, a lot of the warranties are coming back aren't really, warranties of product failure. They are warranties of deposits and limescale and different things of that nature. And some are just, changed with the assumption that they are failed or broken. So obviously when we talk about the efficiency, we're going to be talking about, how that effective efficiency is then eroded like we've done or mentioned here from that standpoint. So that is another piece of that puzzle. And obviously we want to have system water that isn't black or brown or different colors. It should be clear if it's, the water solution that you started with. When you drain that system out or flush it down, it shouldn't have deposits or colors in that. And that's part of this process when we're talking about doing our water treatment. So obviously the benefits of water treatment are obviously going to reduce your downtime. You're not going to get that middle of a winter, breakdown where you have a system that's completely down. It's, obviously never at the ideal time from that standpoint. So it's going to reduce your maintenance and your downtime and obviously callbacks with your customers. So obviously we want to talk about creating a cure. How do we create that cure? So we're going to talk about the prevention that our product can make. The one thing I'll mention at this point is anytime we start with a system, if it has not been cleaned and flushed and dealt with, if we start putting inhibitors in that system, that doesn't make the system, it's not going to clean the system out. It's just going to stop the system from getting worse. At the end of the day, we still need to find devices or ways to either flush or remove the particulates and the pollutants out of that system. We're going to talk about that from a couple of different spaces here. So we're going to talk about how we create the solution, and we're going to utilize Fernox products to create a solution that we're going to be able to have put into the system, and that's going to help us balance our inhibitor levels and get us to a place where we're going to be able to have that system to stop corroding or stop making it worse from where it's at this point. So we're going to have kind of a three-step, initial process. Obviously, if there's something that's broken or you have a system where something has failed, you've obviously identified you have a problem, and then we're going to talk about how do we get to a place of solution for that system. So one way we do that is with system testing. We have system testing that Fernox will do at the factory. So if you take a water bottle and send that to us, we would identify what's in your fluid and give you a report of what that is. And then we also would give you a solution of what you should be doing from that standpoint. Part of that process is identifying, do we have biologicals? Do we have sediment? Do we have hardness? Do we have broken down inhibitors? Do we have different components in the system that are really starting to affect the system quality? Sometimes the water is actually not too bad when we do some of these tests. It's just the level of sediments in the system. We have to look at the sediment strainer or some kind of sediment filter that we're going to talk about here when we talk about magnetic filters. Obviously, ideally, you'd love to flush the system. So we're going to talk about the difference. We have products that you will flush and then you will put that product in as an inhibitor. And we have other products that is going to be your inhibitor and your cleaning all in one step. So we'll talk about that. And then we'll get into how do we deal with iron oxide. Iron oxide is a particular problem that is going to become more resident as we get into the different types of technologies that we're going to, such as ECM pumps. ECM pumps, because we're going from a copper wound motor to a permanent magnet solution. If we don't have a device that's going to absorb or remove that iron oxide from that system, because that new ECM circulator has a permanent magnet inside of it, that iron oxide is going to be naturally attracted to that circulator. Most circulators, depending on their size, are either water and system lubricated and cooled through the system water that's coming by it, or if you're in a commercial application, a lot of times that seal will get built up because you have iron oxide, and that's going to lead to a premature seal leak. So either way, are issues when we leave that iron oxide solution into our systems. So obviously we're going to look at cleaning the system. We have a system cleaner, which is a detergent style cleaner. And then if we have a plugged up heat exchanger, we have a more aggressive acidic cleaner. The difference is we do not put our DS40 descaling agent in a whole system just because of how aggressive that is. We would just use our F3 detergent cleaner to get most of that debris and sludge that's in the system and have that be pushed into solution. So when we do flush it down, you're getting as much of that debris out of that system. So you can flush the system doing a power flush, which we'll talk about machines and tools that we have for doing power flush, which is a machine style flush. And then we also have the ability to do a manual flush as well with a mechanical flush. And then we can do additional components, and we've talked about magnetic filters and sediment filtration. And then the final step is obviously putting that inhibitor to balance the water or balance the fluid that we have in our system and keep that at proper levels via doing testing and maintenance on the levels of inhibitor that have been put into the system. Obviously, during the year, you don't know if something has been changed and we added fresh water. We always have to make sure that our inhibitor levels are correct. So that's going to be something you're going to do as part of your maintenance plan throughout the season. So water test kits, we sell a bunch of different water test kits. So this is something you can do for field testing, something that is a purchasable item through Liberty Supply. So you can test out your iron levels, your copper, your hardness, your pH, and also make sure that the F1 or our inhibitor is at the proper level. So this is something we sell a little tube that you fill up with some water, and then you could be able to do your system test before and after. So if you're doing maintenance on a system that's already been inhibited, you could use that same testing function to pull a little sample out, test to make sure that the F1 or the inhibitor levels is at the proper level. You also could do some tests on newer systems or existing systems to make sure that your pH and your hardness are not in check as far as that's concerned. So we're going to talk about all the different solution of the products that we have from that standpoint with the Fernox line of products. So in the smaller versions, we have product that is in both a liquid format, which is that pint bottle to the left, and that skinnier looking bottle is a pressurized canister. So what that means is on a 12-pound standard hydronic system, I can walk up to that particular system, find an access point like a boiler drain. I can put that system into place. And then because it's pre-pressurized, it can overcome the pressure of the 12 pounds. So I'm not draining the system back to add my inhibitor in. So what we end up doing is we end up opening the valve, we assemble our injector tool onto the can and onto our boiler drain, and then we just push the button on top, and that will force that product in. So we're going to talk about our protectant product, which is our inhibitor. We'll talk about the noise silencer, our cleaning products, as well as our leak sealer. So obviously the cleaner is the first step. So if we're going to have a system that we are going to flush, we're going to add the cleaner. For every pint or every express can that we saw there, 1 equals 26 gallons. So for every 26 gallons of system fluid, I am going to install 1 of those cans. If we're on a commercial system, we also have a 2.5 gallon concentrate that you can put into a system or pour into a system. And that is going to do 500 gallons of system volume. So there are some relationships between how much product I use to the system size. So that means we're going to have to go out to the system and kind of calculate how many gallons. The one nice part about all of our system components is you can't overtreat the system. So whether it's the inhibitor or the cleaning product, if you put a little bit too much in, it's not going to affect the system. Our standardized cleaners can stay in solution for about 2 weeks. So if you're going to do a change out or replacement, or you're just going to flush the system down, you can just let it circulate through the system naturally and allow that system to obviously scrub the inside of the system, piping, and all the different heat exchangers, and push that into solution. So obviously, if we're doing a gravity style system, which means we're just forcing it through or forcing that chemical through, from that standpoint, we're going to let that just circulate through. So that's going to be what we call our natural cleaning process. We do have a pump system, so if you want to force that fluid through or flush the system out once that circulation process has been done, you can do it that way, or you can just do it in a standard drain and power bring in additional fluid to kind of flush that system out as well. This is what our flush cart looks like. So that can give you not only the forward flow, connect yourself to a water supply, connect yourself to a drain off point. So you can, when you drain the system, you go right into a floor drain or remove the fluid out of that system. We also go counterflow, which means I have a valve on this cart that will not only go in the normal flow pattern, but it'll go in reverse flow. So you can get into any sediment patterns or pickup patterns from that standpoint. So those are another way or another option for flushing with that system. We also have tools that we can add on, like a magnetic filter that we can put in while we're doing the power flush. So this is bigger than a standard residential, but a little smaller than a commercial. So that gives you kind of an idea of what that looks like. And as I pull that sediment through, we're going to be collecting that iron oxide. So this is going to do another step of removing that item. So what you're looking at here is a filter after it's been gone through the system and we flushed it all out. This is what we grabbed in that filter system while we're doing a power flush. So that goes in line with the power flushing system. We do have customers that'll utilize this. They'll just pipe it in to the system, and when we're just circulating the water through the standard circulator, so it can sit there and grab that sediment as well. So we can do that as well. When we're doing a power or simple flush, we're trying to figure out what is our dissolved solids or how much mineral or how much particulate is still left. So we have a meter for that. So you can take a sample out and install this meter, and you can get an idea of what that looks like. Our DS40, like I said earlier, is a system cleaner for heat exchangers. So you wouldn't run this through a whole system, but if you have a braze plate or a shell and tube or a boiler heat exchanger or a flat plate or something of that nature, you would isolate and then just pump this through. It will change color, so it'll start pink and then it will turn yellow when it's evaporated. So one nice part here is when the system is clean, and you also know when the fluid or the cleaning product has evaporated, has been exasperated from that standpoint. So I want to make sure that we understand that this is a pH of 3, so this is a fairly aggressive cleaner, and we don't want to run this through the whole system, so we don't want O-rings and different components being affected by the aggressiveness of that product. We also have a neutralizer, so it takes any of the acidity out and brings it back to a pH of 7, so there's no contaminants left over. This is a citric style cleaner, so it's not super harmful for skin and different things like that, but obviously this is not something you want to put on your skin or drink or anything like that. So for the heat exchanger side, we also have a cleaner for that. So if you're cleaning out your heat exchangers, we have a heat exchanger that needs to be removed and cleaned once a year. And you have it pretty built up inside of that heat exchanger. We have a product called DS10, which works similar to our DS40. You put it in a little spray bottle with some water, and it is a powder just like the DS40. So that would also be able to break apart your carbon and any of the buildup that would happen in that heat exchanger. So this is talking about the combustion side or the burner side of the system as well. So the main product that we sell on the protectant side, when we're talking about bringing our system out of a flush, we've cleaned the system out, we've got it as flushed out as we can. The next step we're going to do when we get the system bled out and get all the air out of the system is we're going to add our protector into that system mix. So our F1 does two things. The first thing it does is it doesn't allow anything to stick. So you have to think of Fernox F1 as essentially a layer that goes inside your whole system. And now that won't allow your harness to stick or plate to the inside of your system. So that buildup will no longer be able to happen. And it auto balances your pH, which means if my pH is too high, it will lower it. And if it's too low, it is going to raise it. And again, you can't overtreat. So if I needed to put a gallon or 3 pints or whatever the math came out to be, and I want one a little bit extra, it's not going to harm the system and it's not going to send any of the chemistry off. So you're not going to have to worry about that. So we're going to balance our pH. We're not going to allow the hardness to plate. So this is going to be our overall component product from that standpoint. We do work up to 70 grains of hardness. If we are higher than 70 grains, then we can add more F1 to buffer it down. Again, you're going to do some testing on the post side if you are at that level. That's in our market, we don't see that very often, but it does come up once in a while. So I want to make sure that we talked about that. So obviously this is going to give us our protection against any more products. So like I mentioned earlier, if we just put inhibitor in, we don't flush, we don't clean, we don't do anything else, we're going to stop the system from getting worse, but we're not going to deal with any of the existing problems with any kind of the scale, the hardness that's in the system. It's still going to have some efficiency problems, but it's going to stop it in its tracks from getting further damage from that standpoint. So the jobs that we can't flush and clean the systems for a variety of different reasons, we developed a product that is going to work with magnetic filters, and we'll talk about magnetic filters in a little bit here. But this is essentially our F1 that we just talked about, but then we also add a detergent cleaner in there as a part of that process. So now we have a system that is broken down, but we can't have it be down. We will install a magnetic filter that has a strainer built into it or a separate strainer. We will add our F1 and filter fluid, and now we're going to use that strainer and that magnetic filter to remove the dirt and sediment, and it'll also be our replenishment point because we're going to drain that magnetic filter down. That's going to be our replenishment point to add more inhibitor into that system. But instead of flushing the system in a case where you can't, this is going to be the next best thing to doing that. Obviously, ideally, we'd love to flush and clean out everything and then start from a neutrality standpoint. But in some cases, that's not possible. So that's where the filter fluid product came into play the last couple of years. So that's going to give us a different tool in our toolbox so that we can handle dealing with those types of products and those types of situations. We do sell our systems in what we call a commissioning kit, and what that's going to give you, if you don't buy the test kit as a standalone, it's going to give you one bottle in either the Express, which is the injectable style, or that pressurized can that we were talking about, or the liquid. And it's also going to give you some pH test strips. It's going to give you some F1 test strips, so you can kind of test where that system is out from that standpoint. So these are going to be more of a litmus test or just a dip style test, and we'll give you a little card to match up or meet up with those systems. So we have the F1 and F3 product in not only the residential sizes, but we also mentioned we have larger sizes for commercial applications. So we have a 2.5 gallon jug of the cleaner and the inhibitor, and they also have a 55-gallon drum. The 2.5 gallons will do 500 gallons, and the 55-gallon drums will do 10,000 gallons. So, and if we're doing the filter fluid, we make that in a 5-gallon pail, and that will do 500 gallons of system fluid. The next product that we talk about a little bit is our noise silencer. So this is for reducing the oxygenation around different contaminants in the system. So a lot of times you hear popping and hissing in a old cast iron or steel-based boiler or tube boiler. This will help isolate some of those noises down to try to get the system a little bit quieter, maybe to get to a place where you can service it out of season, or maybe you're going to change that boiler out in the next season from that standpoint. So this is a tool that you have to deal with that. We do make a leak sealer. So this works on all materials. So whether it's PEX, galvanized, copper, stainless, brass, all of the different types of systems, it's the same formulation from concentrate. So we're going to use 26 gallons of system fluid. For every 1 bottle of leak sealer, you can combine leak sealer with other products. So if you put F1 in there and you also have a leak, you also can add RF4 into that system to seal up the leak. So if you find a leak that is you're losing so many pounds over multiple days, this won't take care of a gash or something like that, but a small leak that you can't track down and you're having trouble finding, this will seal up those smaller leaks from that standpoint. We've had pretty good success with this product in different applications. We've had customers call us back on, heat exchangers and systems. They put it in and it sealed it up, and they were able to get that system running back again at full capacity. Obviously, if you have a leaking system and you keep re-entering more water, you get more mineral out, which means more potential buildup in the system. Obviously, more chemical or more F1 has to be put in. So we obviously want to get the system sealed so you can treat that once and have that be your process. Because we've been in the water treatment business for so long, we end up having, seen a lot of systems. We got into the glycol business as well. We saw a lot of problems with the glycol out there. One is not all glycols come in a state of neutrality from that standpoint. So what that means is if you test the glycol that you're putting into your system, is it at a 7 or 7.5? We see manufacturers sending out their products at pH levels of 10 and all over the map as far as that's concerned. So we come in a state of neutrality so that you can have your system start. And the F1 is going to automatically balance because we have the F1 built into our Alpha 11 polypropylene style glycol. The other thing we're not going to do is because we're using F1, it's not a phosphate or a nitrate based inhibitor. So that type of inhibitor, the one problem is if it overheats or over a duration of time, it'll eventually become acidic. So that you end up having to change that glycol a little bit sooner than you normally would as far as that's concerned. So we do not utilize those. The other problem with phosphate nitrates is they can actually help in a situation where you have bacteria or algae in your system. It'll help with that growth process. So, or to continue to allow that to happen as far as that's concerned. Again, because we have the F1, you can do 70 grains with our glycol. Again, if you need more, or if you have more than 70 grains, we can add more F1 from that standpoint. Our natural product comes as concentrate. So most glycol comes as a mix or what they call a premix, which means there's a certain percentage of it is glycol and another percentage of it is water. So instead of hauling water, we encourage you to use the water that's on site, whether it's well water or city water or what have you, and no specialized water with all of our products. So from that standpoint, this would be that solution for that particular application. With glycol, you got to remember it is an insulator. So the more glycol or more percentage of glycol that I have in a system, the more energy I need to displace into that fluid to get that temperature to rise. So obviously you want to always make sure you have the proper amount of glycol for your system. So you want to understand the difference between protection level and burst point. So obviously protection is a point where we're still flowing water, and the burst point is at the point based upon those concentration or those mixes of water to glycol where the system will freeze up. So you just want to make sure that you understand what you need for your different applications and systems. If not, you can always call Liberty Supply and we can help you with that process. One of the other tools that has been worked on a little bit more is magnetic filters. And when we get done with the presentation, I'm going to go on camera and show you a display of a live running magnetic filter here at our training facility. But we want to talk about the whys, and we're also going to look at a little video on magnetic filters here as well. So this video is going to be so this video is going to be looking at taking apart a large commercial magnetic filter, but the process is essentially the same as far as that's concerned. So when we're talking about magnetic filters, we're talking about pulling that iron oxide out. We're using rare earth magnets inside of a tube or some kind of shield to allow that rare earth magnet to not be embedded straight into the water. We're going to have that separated by some kind of sleeve or some kind of covering on that magnetic filter. Because they're rare earth magnets, they're going to be heavy strength as far as the magnetism that we're talking about of how we pull that out of the water, or how do we hold that solution out of the water. So what you're looking at here is I believe this is our 2 or 3 inch model. So at the bottom we have a drain port, so we're going to flush down all the water out of the system. All magnetic filters has some version or some way to have the system taken apart so that you can A, inspect, and B, clean that system out. So what you're seeing here is they're pulling off the screws to pull that out. And then what you're seeing there is the iron oxide that was captured at the magnet level. So from this standpoint, this is stuff that we're going to be consistently pulling out of the system and consistently cleaning. All of our Zilmet magnetic filters that we offer also have a basket strainer. So you're not only going to be able to deal with your iron oxide, but any sediment that is floating around the system, we're also going to be able to handle removing that as well. We also have a 2-inch to 1/2 inch, which we call our X-Mag filter, that you also can add a sediment filter, a micron bag style filter that will go inside of this. So you can not only, get the sediment down to a fine level, especially if you have a really dirty system. You're also going to add the bag filter, or you can do an external bag or water style filter for sediment as well. So you're seeing them pull the magnetic filters out of those sleeves that I was just mentioning, and now the iron oxide is free to fall off, and now we're going to remove that from the system. And right here, all we're doing is just washing those sleeves off as far as that's concerned. So we have that ability. So essentially, we're going to pull the screen out. We're going to flush the system down. We're going to clean out the contaminants out of that magnetic filter. This is our capture point. So again, if we're using that filter fluid, this is the place where we would be able to remove all that sediment, all of that debris, as well as be our refill point for any of our inhibitor as far as that's concerned. So there's two different types of magnetic filters that you're going to be able to purchase. One is a bypass or maybe piped in a bypass. Most magnetic filters can be piped either in a bypass like we're looking at here, where we're not putting all of the return water through the system filter or that magnetic filter. They all use a cyclone style or a centrifugal style system. So they kind of spin around, so you will get some sediment out, but that also gives us a great adhesion for removing the magnetism or removing the stainless steel or the steel products that have broken down or the black iron oxide. So typically when you pull that apart, you're going to see great buildup, just like we saw in the video. And this is just looking at some other pictures that we've gotten out of the field of getting some of that sludge and slime out of that system. So when we do that, we're going to see a lot of different particulates. Every system is going to be a little bit different, but generally in those first couple of weeks, you're going to find that you're going to get a ton of debris out, because no matter how much you flush, you're still going to find that there's more material out there that you haven't captured or haven't removed from that system. Because these filters come in all different varieties, there's all kinds of different designs that we work with. One is the ability to change the fitting location. We need to keep the filter in a certain orientation based upon how we need to clean that system out. But we do have on most of our residential style filters the ability to adjust the position, or the smaller filters. So this would be 1 1/4 inch, a 1 inch, and a 3/4 style. You can adjust the position of the fittings. So in those types of applications where we're doing what we call a direct or a flow through, we're putting that system right on the return from that standpoint, so that you can have that filter be 100% of that flow. If you have a system where you can't be down or you can't shut it down, that's where the difference between bypass and flow through. Again, it's just the amount of time that you can have that system down so that you can clean that assembly and put it back together. All of the guts are essentially the same. Even if they plug up, you will get some flow, but it will reduce. And then we'll talk about the magnetism. Each magnet that's in the system has a different rating. It's going to be rated in Gauss, as you're going to see there. So this particular magnet is at 11,000 Gauss. So you'll see ranges from 2,600 or 2,000 Gauss up to 10, 11, 12,000. So that's going to be kind of the range. Typically, a decent magnetic filter should be in that 10 to 12,000 range. It's kind of what we're looking for typically for that system. Obviously, each model has a pressure drop, and that's how we get to sizing. On the Zilmet side, we'll talk about how we have a sizing guide for that. This is that 4-pipe X-Mag that we were talking about. So this gives you a different installation operation so that we can have multiple piping arrangements where we're doing same side or cross patterns or anything of that nature. This is an installation that happened a couple weeks ago, where after the first 3 days, this is the sludge that was removed just by adding that magnetic filter to the process. So because we can do multiple filter positions and we have multiple size systems, so we go from a 1/2 inch to a 6-inch style magnetic filter, there's options out there for all different types of systems depending on what you're trying to get to. And again, there's different accessories. We have our strainer, but we also can have a dosing funnel, additional ball valves to kind of make that process simpler. And then, like I was talking about earlier, we can also put a filter mesh to deal with the fact that we may have sediment that's finer than the basket strainer, which is 100 mesh. can capture. So if that's the case, we can also add that to the puzzle as well. In the larger series, obviously that's more of a floor mount, getting into bigger flanges, more magnetism. So this has multiple magnets in there. So that has, depending on the size, has 4 or 6 magnets that are sitting inside of the solution. But again, they're kind of concealed in those tubes as you saw in the video. So for sizing of this type of product, we've created a nice chart so that you can look at the different size systems, look at your system volume or what is the flow rate through your system, and you can pick out what size magnetic filter would be most appropriate. Because you can look at those pressure drop charts that we looked at earlier and try to calculate it. So we kind of made a simple selection chart. So anything in yellow is going to be an acceptable range for those different types of filters. And then when you're looking at different brands, the one thing you want to look at is that Gauss rating, connection, how easy is it to remove from the system, how flexible is it on piping. All of those different things are factors, but not all are equal. There's not one size that fits all across the brands. So you need to make sure that you look at that carefully when you're selecting the brand, the style, and the make of that system. There's a bunch of different brands out there, and we can walk you through that process of selecting the right one. So a couple of things was the one that we weren't able to show for the online group was this is a residential version of that magnetic filter that we're looking at. So this is showing that component as well as the filter extremity that we have. Obviously the piping is available to be twisted like we were talking about, so you can move this in any direction for those operations, and obviously it can be removed for cleaning the system. What we're really trying to show is how the magnetic filter is working. That's what this display is all about. So obviously we have an ECM pump, we have a magnetic filter, and there's some iron oxide built into that system. So the whole point of this is to show a live running system of what it looks like. If I pull that magnet out and I can see the iron oxide leaving the filter, because right now it was being held captive in this filter in solution. And as I pull that magnet out, you can see that it went back into that water source. If I put the magnet back into that system, you can see how that captures all of that sediment and that iron oxide back into the system. So we're going to hold it captive so it's not sitting in the pump. And now you can see that the water has cleaned itself up just from that simple ability of having this magnetic filter on site. So this does the best job of showing you how it would work in a system application and what you would benefit from when we talk about doing it from that standpoint. So I think that's really the key to the magnetic filters, is really understanding how it's going to benefit your system. You're now going to lower or lessen the etching of the magnetic or the metallic piping system debris that's in there. It's going to hold it captive. Now I could pull this one off just like I was talking about here. I can pull this, this would be the same idea. You pull it off the system, bring it over to a sink, you take your filter out, you clean everything up, put it back together, and we put it back on the system. So that gives you kind of a better visual. Just like we're looking at that video, it shows you how they cleaned it. This really gives you kind of a reaction rate of how fast that material, and this is a 12,000 Gauss magnet, just like this one is. And some of those larger ones have 4 or 5 12,000 Gauss magnets. So that gives you kind of an idea of what that would look like. So it's all part of a puzzle. If you have a system that doesn't have a lot of iron oxide in the water, you may not need to do a magnetic filter. You may just do a strainer. Some folks have just chosen to do the magnetic filter with the strainer because then you get both benefits. If there is any iron on the system because the cast iron circulator is giving it off, you get that benefit, but you also get the strainer, or in lieu of doing a Y strainer that's hard to take apart and hard to clean, this has been a great benefit for folks that want to do more maintenance and make sure that their system is keeping up with the maintenance pact on that side. So those are all items for us to kind of deal with. So, but if you have a straight radiating floor system, we don't have a lot of the iron oxide to deal with. Maybe we're just dealing with the chemical side of it. So there's different paths. That's why every job that we look at or get called about, we kind of ask the questions and try to come up with a solution that makes the most sense. Obviously, there's all different jobs that have all different problems. Sometimes I get samples back that it's strictly a sediment problem. So we just need to get some kind of water filter in there to kind of get the sediment out, whether it's temporary or a permanent filter. We need some way to get that sediment out of the system because the pH and the hardness is fine, but that's just the only issue. So we really just want to identify that because it's really going to relate, as we're talking about, back to your system performance, the longevity of your equipment, longevity of the components and circulators that are in the system. So that is really the whole key to water quality, is making sure that we have a good system that's going to heat transfer effectively and keep your system working for a long time to come.
Awesome. Any questions?
I don't know.
I did such a good job. Nobody
No, everybody is really up to speed.
I just patted myself on the back with that one.
Yeah.
So from an external visual aspect, you talked about the awkward kind of color on
Yep.
the grass and then corrosion buildup outside on black piping, things like that. Is there any other stuff that, for somebody like you who's out with customers, connecting, that would be good visual representation of obviously externally?
So obviously we talked about like the overheating of the heat exchanger,
Yeah.
venting, obviously if you're a plastic vented product and like if it's specifically if it's PVC, white PVC, it'll start to turn brown if it's getting over temperatured, and that may not be the setting of the boiler, but that may just be a byproduct of water quality.
Yeah.
But at least needs to be looked into. So, it's a starting point. From that standpoint, obviously rust on flanges, drips, leaks, anytime you got liquid dripping out of the system, that's typically some kind of pinhole that has happened or is happening. It's just waiting for it to get to a place where it can corrode over. So those are all signs of, you got water quality issues. So there's some places where the water has worked out well, and there really isn't, but that's a minor, component in the world. We see more systems that are having issues or having corrosion issues or having multiple failures, expansion tanks failing consistently. So, sometimes you have to look back in the maintenance records too. It's not just visual. See what has failed on that system, what other components, because sometimes they put 12 expansion tanks in 6 months. It's like, well, that's just kind of a whistle for like, we got to look deeper than just keep replacing those tanks. So well, they've gone as far as putting a line tank or an epoxy line tank because they know it's a problem, but they're not really dealing with the problem. They're just kind of remedying the solution with something that's going to not fail as quickly.
So is testing water quality in your system a as needed thing, or is there a recommended schedule?
It would be part of your recommended maintenance or what your planned maintenance would be. So that would be something that you would do on your 6 month or 12 month, or for at least once a year. I would say that you'd want to at least test. Doesn't mean you're going to do something, but you're going to test for, just like you would test combustion, you would test a lot of other things, gas pressure, things like that when you're on a system. So, so we have a pump, we have our magnetic filter over here, and we're obviously pumping water around that system. The whole purpose to this system is to kind of show how a magnetic filter works. So what I'm going to do is I'm going to remove the magnet out of the canister and put the iron oxide back into solution. So when we do that from that standpoint, we're going to be able to see how much of that system is changed into the black fluid. Is now you're seeing the iron oxide has escaped the filter. It's back out in solution. As I put that magnet back into the system, you can now see that system is now being reabsorbed, and over time you'll see it'll get clearer and clearer and clearer because now we're holding all of that iron oxide inside of this canister, or inside of this ability for the system to kind of hold that in place. This is an example of a standard magnetic filter we have here. So we're talking about being able to adjust the position. We need to keep this canister in the vertical position, but we can adjust the piping. So if I got horizontal piping, or got vertical piping, or it's on an angle. Also, to clean these smaller ones, all we do is we undo the little union nut that's on the back side. I pull this off of the system. I now can open up this canister. And again, we're talking about one that has a filter screen in it, so they'll deal with sediment. But I can pull this whole assembly, go over to a slop sink, wash that whole assembly out, put my replacement fluid after I have reassembled that system back onto the piping. I could reassemble that, fill this back up with my inhibitors, seal everything back up. We have a little air vent on top so we can get air out of the system. If I need to pull the magnet out by itself for some reason, I can pull it out by unscrewing it here and pulling that back out from that standpoint. So this is the smaller one. We talked about that X-Mag as well as being a larger one. So this is our water test kit that we were talking about. So we can test chlorides. We can test for our hardness and our iron and our, as far as that, and our copper levels that are eroded, as well as pH. These are things that you can buy from Liberty Supply. Then you'll have a test kit. So we use a sample bottle to kind of show where we put that in there. If we're doing the F1 inhibitor test, you're going to go up there. It's marked here in milliliters. You're going to want to go up to 10, and then you're going to start doing your test. If you decide that you want some more training, we can kind of go deeper on that to kind of show you how you test for F1, or you can use the test strips, which we have here. So this is what comes in the boiler commissioning kit. So this is the test strips that we have for that as well. So.